Number 21. Sa akin pa nakakita kayo ng ganitong problem. Okay? Sa akin, so yung A natin dyan sa S1 angle 120 degree, di ba? So yung ginagamit natin sa sequence currents, di ba? Sa akin, so sa pagko-convert natin from phase currents to sequence currents or sa phase voltage to sequence voltages. Okay? So then, so A squared plus A plus J. Sa akin, so yung A natin is 1 angle 120, kaya yung A squared natin is 1 angle 240 degrees. No? Okay? So then yung A natin is 1 angle 120 degrees. So then we have the imaginary number J. No? Okay? Sa akin, so note, diba? So na, pwede nyo gawin dito para hindi nyo na kailangan i-compute, diba? So is mag-a-add lang tayo ng 1 dito, tapos minus 1. So para nag-add ka lang ng 0. Kasi remember, so A squared plus A plus 1 is equal to 0, diba? Kaya lalabas sa atin is negative 1 plus J. Okay? So we have negative 1 plus J, diba? Okay? So kaya yung sagot natin dito is letter C. But again, you can calculate sa calculator. Diba? Okay? So we have complex mode. So 1 angle 240, okay, plus 1 angle 120 plus J. Okay? So we get negative 1 plus J. So pwede nyo gawin yan. So para hindi nyo na kailangan i-solve. Diba? Makukuha nyo kaagad yung sagot. Next number, 22. No? A hydroelectric generating station is supplied from a reservoir, so capacity of, okay, 5 times 10 to the 6 cubic meters at a head of 200 meters. Find the total energy available. Okay, okay. So again, so remember, okay, so mula sa discussion natin ng power plant, okay, so again, so ang kailangan natin dito is the energy output, diba? So ng electric power plant natin, ng hydroelectric power plant natin. And this is just given by the output power. Okay, so then multiplied by time t, di ba? And remember that the output power, okay, for a hydroelectric power plant is given by the efficiency times the volume flow rate times the specific weight, di ba? So water, kasi hydroelectric, times the head, di ba? Okay, so ibig sabihin, so this will be given by, okay, so multiplied by time t, okay? So and remember, di ba, so dito sa equation natin na to, okay? So itong Q, the volume flow rate, is the rate of change of volume with respect to time. Diba? So, ibig sabihin, on the average, diba? So, again, so this is equal to the change in volume over time. Kaya pag minultiply mo ito ng time t, so pag pinag-multiply natin to, so this is our volume V. Diba? So, again, this is the amount of volume, diba, na available sa atin. So, again, so para mag-produce ng electricity. Diba? And sabi sa problem, okay, ito yung capacity natin. Diba? So, ibig sabihin, ito yung i-assume natin na amount of volume na pwede natin gamitin to generate electricity. Kaya ibig sabihin, ito yung volume V na gagamitin natin dun sa equation. Okay? So then, okay, so again, from the given, so this is 75% yung efficiency. Okay? So this is 0.75. So again, itong Q times T, gawin na natin volume V. That's 5 times 10 to the 6. Okay, so this will be cubic meters. We have omega. So ang gagamitin ko dito sa omega is 9.81. Okay, so times 10 to the 9.81. So kilonewton na to. So kilonewton per cubic meter. Diba? So then multiply this by the head. Diba? So sabi dyan, so we have a head of 200 meters. So this is 200 meters. Diba? So then, so we can cancel dito yung cubic meter. Okay? Diba? So then, so para may convert natin to sa kilowatt hour, diba? So kasi remember, so kailangan natin is kilowatt hour for this problem. Okay, so ito naka-kilonewton meter, this is kilojoules. Kilojoules is kilowatt second. So kayo sabihin mo multiply pa natin pa ng 1 hour for every 3,600 seconds. Okay? So yung kilonewton meter per second, so again, that's kilowatts. So kayo magigitong kilowatt hour. Okay? Okay? So again, so this is our energy output. Okay? So pag sinolve natin to, okay, so again, so you should be able to get 2.044 times 10 to the 6. So again, so this will be kilowatt. No. Okay? So this is letter B. Next number, 23. So number 23, ito yung mga tatandaan natin. Pag direct lighting fixture, diba? So again, so ibig sabihin nito is 90% and above, downward, diba? So yung direction, okay? So again, pag indirect, so again, so this is 90% and above. Ang direction naman nito is upward, diba? So tapos pag semi-direct, diba? Semi-direct lighting, okay? So this is 60 to 90%. The direction is downward, diba? Pag sinabi naman natin semi-indirect, okay? So again, this is 60 to 90%. So again, so the direction is downward. Okay? Nakaba? Kaya din sa problem na to, sa number 23, okay? So again, a direct lighting fixture directs at least, that's 90% downward. Diba? So kaya we have letter A. Okay? So this should be upward. Okay, so next number, 24. Okay, so again, so this time, so we have a series RL. So kasi nga coil yung nakalagay sa problem, diba? So we have series RL, so resistance, so then we have inductance, okay? So tapos this is connected across a battery, okay? Or at least a DC supply, diba? So let's assume battery na lang, diba? So para simple lang, okay? So again, so this will be our E, so this is R, so then this will be L, okay? Okay? So now, let's assume, diba, that this is connected for a very long time, diba? So again, so if this is connected for a very long time, so then short circuit na lang yung inductor natin, okay? Diba? So which means the current, so flowing through the circuit, so current I, so again, so it's given by, so again, this is E over R. So we have from the given, that's 20 volts divided by 2 ohms. Okay? Diba? So ito yung question natin. Diba? So coil 10 Henry, so and resistance is 2 ohms, supply that 20 volts. Diba? Okay? So yung current na nagpo-flow sa atin so is 20 volts divided by 2 ohms. Okay? So again, so this will be given by 10 amperes. Okay? Diba? So ibig sabihin, so if the switch, so let's say ito yung switch natin, is in-open natin, diba? So then sabi sa problem, okay, so again, so what is the average EMF induced when the circuit is opened and the current falls to 0 in 0.5 seconds? No? Okay? So kaya ibig sabihin, diba, sa akin, so ano ba yung average EMF sa inductor? So this is negative L, change in current divided by time t. Right? Okay? So again, so then this will be given by, okay, so we have negative, so again, so we have the inductance. So that's 10 Henry. Okay? So times delta I, so again, change in current natin is from 10 ampere, magpo-fall siya sa 0. Diba? So this is 0 minus 10 ampere. Okay? So divided by, so this is 4. Sabi sa problem, 0.5 seconds. Okay? So pag sinolve natin to, this will be 200 volts. Okay? So yung sagot natin dito is letter D. Diba? Okay? So next number, 25. Okay? So number 25 sa akin, so this is just yung zip-on over 68. Diba? So generated EMF in a DC generator. Okay? Naku ba sa akin? So una, kailangan muna natin ng number of parallel path. Diba? So this is a lap wound armature. Okay? So pero walang sinabi tungkol sa plex. So again, we will assume simplex. Okay? Naku ba? So therefore, kung simplex lang to, okay? Sa akin, kung simplex lang to, diba? So assume simplex. Okay? So then the number of parallel path is equal to MP kasi lap winding. So again, this is 1. So the number of poles is given as 4. Diba? So again, so then A is equal to 4. Okay? So then, solving for the generated EMF, so again, so this is simply zip-on over 68. No? So again, so this is given by, so again, the number of conductors is given as 480. Number of poles 4. The flux is 25 milliweber. So again, milli means negative 10 to the negative 3. Diba? So again, so this is Webers. So then the speed is 600 RPM. Okay? So again, so this is 600 RPM. So then this is divided by 60 times the number of parallel path. Diba? So that's 4. Okay, so pag sinolve nyo to, so again, so this is 10. So then we have, this is 0.025 times 10 is 0.25. So 1/4 ng 480 volts. So again, that's 120 volts. Okay? So ngayon sagot natin dito is letter B. Okay? Okay? So next number, 26. Na? So itong number 26 naman, diba? So actually wala tayong ganitong category sa Pilipinas. Okay? Okay? So kung babasahin nyo dun sa distribution code natin saka dun sa grid code natin, yung sa distribution code natin hanggang high voltage lang. Kasi wala namang extra high voltage sa distribution system. No? So then, sa grid code naman hanggang extra high voltage lang. Kasi wala pa tayong ultra high voltage na transmission system sa Pilipinas. I don't know kung nag-update na sila, pero alam ko kasi 2017 yung pinaka last diba, so na grid code. No? Okay? So kaya again, so hanggang extra high voltage. Pero again, so sa ibang bansa kasi merong ganito. Diba? So ultra high voltage. Okay? So kaya yun yung gagamitin natin. Okay? Okay? So again, parang doon sa mga estudyante na hindi nakakasabay doon sa lecture, so again, i-upload ko naman yung recorded video. No? Kasi pag every time na magre-request kayo na bumalik dun sa page na yun, okay, sa akin, so masasayang yung time natin, okay, nakabasa for the lecture, okay? So kaya again, so kung meron kayo na miss, diba, so then balikan nyo na lang, okay, nakabasa. So i-post ko naman ito, pinakamatagal hanggang bukas, okay, nakabasa. So yan. Okay, so next number, again sa 26, so yung tatandaan nyo dito, pag low voltage, diba, sa aking classification natin sa Pilipinas, again, so this is below 1 kilovolts. Okay? Okay? So pag naman medium voltage, so medium voltage, okay? So again, so ito yung 1 kilovolt, diba? So up to 34.5 kilovolts. Okay? So pag naman high voltage, okay? So this is 34.5 kilovolts, diba? So up to 230 kilovolts. Okay? So pag naman extra high voltage, so ito yung 230 kilovolts, diba? So up to 765 kilovolts. Okay? Tama ba? So then we have the ultra high voltage. Again, ito sa ibang bansa pa lang meron ito, diba? So I'm not sure kung magkakaroon tayo dito sa Pilipinas. Okay? So again, this is 765 kilovolts and above, probably, diba? So kung magkakaroon man tayo sa Pilipinas kasi yun yung kasunod ng extra high, diba? So kaya ibig sabihin, so again, so dito pasok yung 1,000 kilovolts natin. So therefore, this should be letter D. Okay? So any questions? Number 26. No? Okay? So next number, 27. No? So for number 27, so we are dealing with the speed of DC motors. Okay? Nakaba? Pagdating sa speed of DC motors, okay? So again, so dalawa lang yung pwede nating tignan or yung tinitignan natin, di ba? So pag i-consider o pag i-compute natin yung speed, di ba? So one is the loading, di ba? Kasi from the loading, so we can calculate the torque, di ba? So and from the torque, we can calculate the speed, di ba? Sa akin, so yun yung tatandaan natin pagdating sa ano natin, speed, diba? So and pwede rin naman natin gawin is tignan is yung EMF, diba? So kasi alam natin we have the econ formula. So therefore if we solve the EMF, diba? So we can solve the speed. Okay? Sabit lang na. Okay? So akin sa either loading or the EMF, diba? So and in this problem, so we are given a series motor. So tapos dun sa second condition natin, nagdagdag tayo ng resistance, diba? So additional resistance means additional voltage drop, diba? So kaya ibig sabihin nun, so maapektuhan yung EMF, diba? So nung motor natin, so kaya EMF yung gagamitin natin for this problem, okay? So again, so for our first case, diba? So again, case number 1 natin, okay? We only have the series motor, okay? And sa problem natin, so again, as you can see from the given, okay? So we are given here a series motor, diba? So makikita nyo dito, diba? So na pinagsama na yung resistance natin. So we have a total resistance. So sabihin, so ito na yung total combination. So no series field natin. So we have the series field and the armature. So we have the series field and the armature. Okay? Nakabasa, pinagsama na yan. So tapos sabi din sa problem, diba? So na, okay? So nung pag magko-connect tayo ng 5 ohm resistance in series, okay? Nakaba? So then the motor will be taking the same current from the same supply. So ibig sabihin yung terminal voltage natin, so ito, 220 volts saka 10 amperes, pareho lang yung value niyan, diba? So in the first case and in the second case. Okay? So okay, so let's start with the first case. Diba? So 0.8 ohm yung total resistance. So we have 600 RPM yung speed. Tapos 10 ampere yung current, 220 volts yung terminal voltage. Okay? So ibig sabihin, so this will be, gawin ko na itong total resistance, pagsamahin na natin. So then this will be the back EMF. Diba? Okay? So this will be our total resistance, back EMF. Okay? So and this will be the terminal voltage. Okay? So and this will be our current. Diba? So tawagin natin as our line current. Okay? Nakabasa din. So what is our back EMF? Okay? So from this circuit, so this is simply the terminal voltage, KVL lang, minus, okay, so total resistance times the line current. So therefore, this will be, so from the given, that's 220 volts minus 0.8 ohm multiplied by 10 amperes. Okay? So if you try to solve this, you should be able to get 212 volts. So again, that's our back EMF. Okay? So now, for case 2, so tawagin ko ito as EB1. Diba? Sa akin, so para ma-differentiate natin from case 1 to case 2. Okay? So again, for case 2, no? Meron tayong series resistance. No? So kaya that will be, okay, so let's say ito yung series resistance natin. Okay? So tapos ito yung ating total resistance. Okay? So then this is our back EMF. Okay? So then this will be our terminal voltage. No? Okay? So then this will be our total resistance. This is our series resistance. Diba? So yung dinagdag natin. So na resistance. Tawagin ko na lang as R. So tapos ito yung total resistance natin. Ito yung back EMF. Okay? And this is our load current. So tawagin ko naman dito yung back EMF natin as EB2. So again, ayon sa problem, walang pagbabago sa current saka sa voltage. Diba? So yun pa rin yung gagamitin natin. So therefore, EB2 this time so will be given by VT minus. So again, so series combination ng additional resistance saka ng total resistance natin. So multiplied by the line current. Okay? So therefore, this will be 220 volts minus 0.8. No, this is 5, yung R. Okay? So again, this is 220 volts. Diba? Minus, again, this is 5 plus 0.8 ohm. Diba? So then this is multiplied by 10 amperes. Okay? So then this will be given by, so 162 volts. No? Okay? So this is 162 volts. Okay? So again, so this is our EB2. Okay? Okay? So then again, so next is ratio and proportion na lang. So again, using the Econ formula. So EB2 over EB1, diba? So is equal to, okay, so we have K2 or K, so times Phi2 N2, diba? So divided by K, so Phi1 N1. So again, same machine lang yung ginamit natin. Nagdagdag lang tayo ng resistance, so therefore dapat pareho lang yung constant natin dito. Then how about the flux? Okay? So remember, saan ba nakadepende yung flux natin, diba? So this is a series motor. So this is directly proportional to the series field current, diba? But as you can see dun sa circuit natin, the load current or the line current are the same, diba? So ibig sabihin yung series field current natin are also the same kasi remember for a series motor, IL, diba, is equal to IS, diba? So ibig sabihin, so since hindi nagbago to, so hindi rin magbabago to, hindi nagbago to, therefore hindi magbabago to. So therefore the flux is the same. The flux is constant, no? So kaya kung yung flux natin ay constant, so we can cancel this. So then solving for N2, this will be EB2, that's 162 volts, divided by EB1, that's 212 volts. So then multiply this by N1. What's N1? 600 RPM. Okay? So pag sinolve nyo to, you should be able to get 458 revolutions per minute. Okay? So this is letter B. No? So any questions? Ask para dito. No? Next number, 28. No? Okay. So the current in a circuit is given. So given your frequency, how long will it take for the current to rise to 25 amperes? Okay. So again, so nakalagay dito, again, so nakalagay rise to. Diba? So ibig sabihin, so ito yung ating current na gagamitin. Iba, it's a different matter kung yung nakalagay is rise by. Diba? So although pareho lang din siya dito sa problem na to kasi 0 amperes naman yung initial current natin. Okay? Okay? So pero again, so pay attention to that preposition. Diba? So medyo nakakalito yung part na yun pagdating sa mga problems natin. Okay? So okay, so number 28, so we are given that the current, diba? So is equal to 50 sine omega. So again, saan equal yung omega? Omega is 2 pi f. Diba? Okay? Okay? So again, so this is 2 pi ft. Okay? Okay? And again, so what we want to solve is the current is equal to 25 amperes. So therefore, so by substitution, so 25 is equal to 50 sine of, this will be 2 pi, so by 25 hertz. Diba? So then multiply this by time t. Okay? Okay? So then solving for time t, diba? So yung una natin gagawin dito is arc sine of 25 over 50. Okay? Okay? So just remember, diba? So na, okay? This is radians per second. Diba? So meaning this is in seconds. Diba? So kaya this will be, so yung buong nasa loob ng sine natin is radians. So kaya ibig sabihin, so itong buong to, so dapat ito ay naka-radians. Okay? Okay? So okay, so just remember that. So that this should be radians. Okay? Okay? So ibig sabihin, okay? So that is in radians. So dapat naka-radians mode kayo or kung naka-degree mode man kayo, pagka-solve nyo ng degrees, i-multiply nyo ng pi over 180. Diba? So then this is divided by 2 pi multiplied by 25 hertz. Okay? Okay? So yung makukuha nyo dito is 3.33 times 10 to the negative 3. So this will be in seconds. Okay? So this is letter B. Okay? So next number, 29. No? So number 29, so we are dealing with the eddy current loss here. So we have eddy current loss, diba? So tapos, guys, again, so we have 50 watts, no? Yung original eddy current loss natin. Tapos ang makikita natin dito, yung nagbago lang dito is yung EMF natin, diba? So yung voltage, okay? So remember, sa eddy current loss, meron tayong dalawang equation. Yung isang equation, ang tinitingnan natin dyan is yung pagbabago sa flux density saka sa frequency, diba? Yung isa naman is yung pagbabago sa voltage saka sa frequency. So dito ang given sa atin is yung pagbabago sa voltage. So therefore, ang gagamitin natin is yung pangalawang equation, diba? So ng eddy current loss. Okay? Okay ba? So let's try that. Okay? So number 29. Okay? So we have, gagamit lang ako ng ratio and proportion. So again, ang gagamitin natin na equation is yung second equation natin sa eddy current loss, that is equal to this one. Diba? So again, we have PE2, diba? So divided by PE1. So then this is equal to, so we have KE, so then we have E2 squared. So then divided by, so we have KE, so then we have E1 squared. So then magka-cancel lang to, diba? So then solving for PE2, okay? So again, so this will be given by, so again, so the new voltage is 330 volts. The original voltage is 220 volts. So again, so this quantity is squared, okay? So then we multiply this by, okay, so again, so the original eddy current loss, that's 50 watts, okay? So then, so you will solve that this is 112.5, okay? So we have 112.5 watts. Okay, so this is letter B. Okay, so any questions here? No. Next, number 30. Okay, so inductance affects the direct current flow at the time of the back. So okay, so remember, okay, so during operation, okay, the inductance, diba, for a direct current is just a short circuit. So hindi siya nakaka-apekto doon sa direct current natin. So makaka-apekto lang siya during turning on saka turning off, diba? So kasi dyan tayo nagkakaroon ng charging saka discharging. No? So again, so this is letter A. Okay. So next, number 31. Diba? Surge impedance. So again, so ito nasa lecture natin. Diba? So again, the surge impedance is given by square root of L over C. Okay. So this is letter D. Okay. So next, number 32. So we have this. Okay. So number 32, so this is an induction motor, di ba? So ipa-follow lang natin yung power flow diagram sa induction motor, saka mga equations natin sa induction motor. Okay, nakaba? So okay, so may copy naman kayo nito. So diretso ko na sa solution. Okay? So again, ang given sa atin, di ba? So for number 32 is the input power to the induction motor. And remember, sa power flow diagram natin, this is just equal to the input power sa stator, di ba? So input power to sa stator. And again, from the given, this is 30 kilowatts. Diba? So we will start here. Okay? Nakaba? So now, okay, so then we can now calculate the output power sa stator. Okay? So this is simply the input power sa stator minus, okay? So input power sa stator minus the stator losses. Diba? So again, stator losses to. And again, so this is equal to the input power sa rotor. Ito yung pumapasok na power sa rotor natin. Okay? Nakaba? From the power flow diagram. Diba? So therefore, so this will be 30 kilowatts from the given. Yung losses natin ay 1 kilowatt. So therefore, this will be 29 kilowatts. Okay? Nakaba? So this will be our rotor input. Okay? Nakaba? So now, mayroon tayong equation for induction motor. So okay, so nasa discussion natin to. So that the developed power, diba? So will be given by, okay? So this is 1 minus the slip S multiplied by the rotor input, diba? And base dun sa problem natin, the slip is equal to 4%. So 1 minus 0.04. So then this will be multiplied by 29 kilowatts. Okay? Tama ba? So that is 0.96 multiplied by 29. So we get 27.84. Diba? Okay. So again, so this will be our developed power. And again, from our power flow diagram, so for an induction motor, yung output power sa rotor, so this is equal to the output power of the machine. Diba? So this is given by the developed power minus the rotational losses. Diba? So which is the same as the friction and windage. No? And base dun sa problem natin, ang given sa atin ng friction and windage is 1.5 kilowatts. So this is 26.34 kilowatts. Diba? So meron na tayong output power. Okay, so the last thing will be the efficiency, which is output over input multiplied by 100. Sa akin, yung output na kuha natin is 26.34 kilowatts. The input is given 30 kilowatts. So multiply lang na natin na 100 to get that percent value. So then this will be 87.8%. Okay? So kaya yung sagot natin dito is letter B. Okay? So next number, 33. Okay? So ito na lang din to, change of base, di ba? So again, so from 500 MVA naging 100 MVA yung base natin. From 18 kV naging 20 kV, di ba? So dito meron ka rin change in voltage. The original per unit is 0.25. So hinahanap sa atin is yung bagong per unit, di ba? So ito yung bagong per unit natin. So again, so this is given by, so again, the new base over old base power. So then multiplied by the old base over the new base voltage squared, multiplied by the original per unit reactance. Diba? So again, so this will be given by, so again, from the given, yung bago nating base power is 100 megavolt ampere. Yung original nating base power is 500 megavolt ampere. Diba? So then multiply this by, so again, the original base voltage is 20 kilovolts and the new base voltage is 18 kilovolts squared. The original per unit reactance is 0.25. Okay? Pag sinolve nyo to, you should be able to get 0.0405 per unit. Okay? So ito yung bago nating per unit reactance. No? So this is letter D. Okay? Number 34. So again, another objective question. Basic function of a circuit breaker. So again, this is extinguish the arc. Diba? So we have letter D. Okay? Nakaba? Next. Okay? Number 35. So this is Philippine Electrical Code, diba? So just note for number 35, meron tayo ditong troubleshoot. Okay, nakaba? Yung mga meters sa choices dapat millimeters, diba? So this is kind of obvious naman. So kasi masyado malaki yung meters, diba? Para sa isang closet space. Okay, nakaba? So yung 150 meters, diba? Sa akin yung closet space mo. Okay? So kalahati lang yun ang closet space actually. No? Kasi nasa gitna yan. Okay? So yun yung minimum clearance ng recessed incandescent fixture. Diba? Sa akin ito makikita natin sa PEC. So 2017. So sa latest na to. Diba? So under section 4.10.2.7 C3. Okay? Diba ba? Nakalagay dyan ko yung mga uri ng lamps natin, mga uri ng fixtures. Tapos kung ano yung minimum nila na layo mula dun sa storage space. Okay? Tama ba? So again, so this is 150 millimeters. Okay? So this is letter B. Okay? So tapos sila natin ang number 40. No? So then lunch break tayo. Okay? So number 36, di ba? Sa akin ito troubleshoot din. Di ba? So meron nawawalang given. So pero may pattern naman. So kaya dapat nakuha nyo pa rin. Okay? So kasi mga ganito din yung halos yung mga makikita nyo na troubleshoot pagdating sa board examination. Kaya masanay na kayo sa ganyan. No? Madalas ang troubleshoot talaga sa EE saka sa math. Okay? Naka ba? So doon pinakamaraming troubleshoot sa pre-board natin. Okay? So again, this should be 40 ohms. So ito nawawalang given. So again, so we are given, we want to get the total resistance if they are connected in parallel. So 1 over R1. Diba? So plus 1 over R2. Plus 1 over R3. Diba? So then plus 1 over R4. Okay? So again, so then this will be given by, so again, so we have 1 over 10 ohm. Plus 1 over 20 ohm. Plus 1 over 30 ohm. Plus 1 over 40 ohm. Diba? So then, reciprocal. No? So again, so this will be given by 4.8 ohms. Okay? So therefore, so this is letter B. No? Okay? So next number, 37. As the load is increased, the speed of a DC shunt motor so will be blank. No? Okay? So again, so number 37. Okay. So na itatandaan natin for a DC shunt motor, diba? So DC shunt motor is actually designed for constant speed, diba? So although, di ba, sa akin, so this is the ideal condition or the theoretical condition natin sa akin, so for a decision motor. Okay, nakaka? So in reality, di ba, so meron tayong speed regulation for shunt motor. So although very small, okay, nakaka? Bumababa yung speed niya, di ba, so habang tinataasan natin yung loading, okay, nakaka? So kasi nga, di ba, so pag isipin niyo lang, di ba, so for example, nagra-run yung motor natin, tapos nagdagdag tayo ng load, so bibigat yung load natin, so then babagal yung speed natin. Okay? Tama ba? So ganun yung nangyayari in reality. Diba? Sa akin, so hindi siya katulad ng synchronous motor na yung speed kasi ng synchronous motor nanggagaling sa magnetic field. Diba? So that's why, okay, so constant lang talaga yung speed niya regardless of the loading. Okay? Yung DC shunt motor natin, nagbabago pa rin yan kahit pa paano. Okay? Tama ba? So that's why yung sagot natin dito is yung reduced slightly. Diba? So we have letter D. Okay. So next number, 38. Given sa atin yung conductor radius, hinahanap yung area and circular mills, diba? So again, so area and circular mills is diameter squared, no? So kaya bago nyo siya, para makuha natin circular mills, dapat diameter. So isa yung radius, i-multiply pa natin ng 2, diba? So kaya this is 0.1625 inch. Naka-multiply ng 2. Convert natin sa mils. So we have 1,000 mils per inch. Okay? So then this quantity squared. Okay? So pag sinolve you to, you should be able to get 105,625 circular mils. No? So this is letter. Okay? Next, 39. Diba? So number 39, so remember that this is Y delta. Diba? So ibig sabihin, this is delta connected yung secondary natin. Diba? So this is delta connected. So ibig sabihin kung delta connected yan, okay, so then, so parang ganito yung secondary natin, yung lalabas sa atin na line voltage dito, diba, is the same as the per phase voltage natin dito sa transformer natin. Okay? So again, so pareho lang siya dun sa per phase voltage natin dito, which is from the given 240 volts. Diba? So this is 240 volts. Okay? Tama ba? So, ibig sabihin yung base voltage natin, so remember, pag 3-phase, the base voltage is usually in line to line. So, ibig sabihin, so ito na mismo yung gagamitin natin yung base voltage, which is 240 volts. Okay? Kaya yung sagot natin dito, letter B. Okay? So, we have 240 volts. Okay? So, this is letter B. Okay? So, then number 40. Okay? So, again, another objective type. So, we have the power factor of an alternator is determined by its blank. Diba? So kahit ano namang machine, diba? So yung power factor is determined by load, diba? So this is load. Okay? So itong speed, so this determines the frequency, so which determines the EMF, diba? So the generated EMF of the alternator. Okay? Tama ba? So itong excitation determines the flux, which also determines the generated EMF, diba? Kasi yung equation natin for generated EMF so is equation natin sa generated EMF is 4.44 frequency times the number of turns times the flux. Diba? Prime mover determines the speed. Diba? So kaya pareho lang siya dito. So yung speed, so then frequency, so then generated EMF. Okay? So itong load, diba, sa akin is determined by, determine its power factor. Kasi again, this determines the power. Okay? Nakaba? So kaya dyan natin makukuha yung power factor natin. Okay? So ang sagot natin sa number 40, so is letter B. Okay? So any questions so far? Okay, so sa E. No? Okay.